dy by dx is equal to function of x comma y in the numerator and function of x comma y in the denominator. So if we see the numerator one, it has to be homogeneous function in x and y. And if we see the denominator, it has to be homogeneous function in x and y. Now, what do you mean by homogeneous function? Homogeneous function is a function in x comma y where all terms have same degree. So if you write f of x comma y, it may be like x square minus 3xy plus y square. So you can see that there are three terms and all the three terms have 2 degree. This is have 2 degree. Here x power 1, y power 1. So add up to 2 and y has 2 degree. Similarly, gxy will also be also homogeneous function. One more thing, that apart from being homogeneous functions, they must also be of same degree homogeneous function. This also we have to keep in mind, that f of x comma y and g of x comma y are definitely homogeneous functions in x and y, and both are of same degree. Like if you write this one, x cube minus 3x square y plus 7xy square plus y to the power 3 or 7y to the power 3. So this is homogeneous function of degree 2. And below one is also homogeneous function, but it is of degree 3. So though both are the homogeneous functions, but they are of different degrees. So one thing more is to be keep in mind, that they must be homogeneous functions and they must be homogeneous functions of same degree homogeneous function. So you can't take one of 2 degree, another of 3 degree. Both will be either 3 degree, both will be 2 degree. Then this is called differential equation, homogeneous differential equation. Yeah. So if we take some example, for suppose it says that show that x minus y dy by dx is equal to x plus 2y is homogeneous and solve it. When you will do this, what you will have, that it is dy by dx is equal to x plus 2y by x minus y, and it is homogeneous because the numerator is of 1 degree and all the terms are of 1 degree. The denominator is also of 1 degree. So this is homogeneous function of 1 degree, and this below one is also homogeneous function of 1 degree. So this is homogeneous differential equation. Now, what is the way to proceed in homogeneous differential equation? We take let y is equal to vx. When we differentiate y, it will become dy by dx is equal to v plus x dv by dx. So we can do this. Now, after doing this, what we get is here x minus y is vx. Or let us take this one where we have reduced it into homogeneous. So dy by dx will be from here v plus x dv by dx is equal to x plus y will be x plus 2y will be 2vx. Here x minus y will be vx. So x common 1 plus 2v by 1 minus v, because x will get cancelled. Now in the next step, what we will do, we'll write x dv by dx is equal to 1 plus 2v by 1 minus v minus v. It will be 1 plus 2v minus v plus v square by 1 minus v. So it is 1 plus v square by 1 minus v. Can we write it like this?
Yes, sir.
Okay. So this is dv by x dv by dx. Now it is easier to do variable separable. I am not going fast now. I hope you are following the steps.
No, yes, sir.
Okay, if I'm going fast somewhere in calculation, you can tell me, because I think these are calculation parts, so I move fast. So this will be 1 minus v by 1 plus v square dv is equal to dx by x. So we can write it like this. So now this is variable separable. This is what we have done earlier. So v with dv and x with dx. So now when we integrate them, what do we get is, we have to integrate left and right. So in order to integrate left, we know that denominator is 1 plus v square. So let us see the derivative of denominator, which will be 2v plus 1. Derivative of 1 plus v square will be 2v plus 1 on differentiating. So we write it somehow that it is, we will adjust, or we can also write it here like a into 2v plus 1 plus b is equal to numerator 1 minus v. Now if we equate them, we say that 2a is minus 1 and a plus b is equal to 1. So we get a is equal to minus half and b is equal to 3 by 2, which means this 1 minus v, which is the numerator, can be written like this. A is minus half, 2v plus 1, and b is 3 by 2. Now if you simplify it, you will get the required numerator, 1 plus v square dv. And purpose of doing this is log x plus c. Here we don't have to do much. And this is all integration now. So purpose of doing this was so that you can separate them. So this will be minus half integration of 2v plus 1 by v square plus v plus 1 dv plus 3 by 2 dv by v square plus v plus 1 is equal to log x plus c. So we can write it like this. We can separate both of them and integrate. Now when we'll integrate the this one, the first one is having derivative in the numerator and the term in the denominator. So that will be log of mod of v square plus v plus 1. Another one will be 3 by 2. You have to complete the square. You remember that. This will be v plus 1 by 2 whole square. So v square plus v, you will get plus 1 by 4. So you have to write here root 3 by 2 whole square. So 3 by 4 is equal to log x plus c. Now v is equal to y by x. So we can write it as minus half log of y square by x square plus y by x plus 1 mod plus 3 by 2. And here the integration of this is 1 by a square plus x square is 1 by a into tan inverse of x by a. This is what we are going to get, is equal to log x plus c. And then we can write it as minus half log of y square plus xy plus this would become x square by x square. And here 2 will cancel, root 3 times is 3, tan inverse v you can put as y by x. So this will be y by x. In that case, it will be 2y plus x by root 3x. Yeah, is equal to log x plus c. So in the next step, you have almost got the answer. This is your answer, but you want to simplify this, you can simplify. Like you can write it as minus half log of y square plus xy plus x square. And then this is minus log of x square. So it will become plus 2 log x by 2. So log x it will become, right? Log x square will become 2 log x and 2 will cancel. And it is also division. So minus minus will plus. So it will be root 3 tan inverse 2y plus x by root 3x. This will you will get is equal to log x plus c. And log x will get cancelled from both the sides. So it is better to do the simplification. So finally, it would become minus half log of y square plus xy plus x square. So this is quite lengthy question. I was not expecting this question so lengthy. So 2y plus x by root 3x plus c. This will be your answer. Let me check the answer because it is among the solved examples. So they have given the log x square plus xy plus y square. Yeah, it is fine. Is equal to 2 root 3. That will work. And tan inverse 2y plus x by root 3x plus c. Okay, they have taken it plus, so maybe plus minus issue. Oh, sorry, I did a small mistake. This is plus sign here, not equal to. Equal to is here. So this is a plus sign. This is a plus sign. So if it will go there, then it will become half log x in plus is equal to this. So they have given answer like this, that it is log of y square plus xy plus x square is equal to 2 root 3 tan inverse 2y plus x. So all of your integration concepts is being revised here. Have you got it?
So how did 1 minus v change to that minus half part? I didn't understand that.
1 by where?
So the no, so the first part, the 1 minus v, it changed to minus half 2v plus 1 plus 3 by 2, right?
Yeah, that is basically we used to do in integration. That this is 1 minus v. Now we want to integrate this. How will you integrate this? So you will take 1 minus v as a times denominator's derivative. So that will be 2v plus 1 plus constant. Now a suitable value of a and b can be found out by equating the coefficients. That is 2a is equal to minus 1 if you equate the coefficient of v, and a plus b constant is equal to 1. So you give, on solving, we got here minus half and 3 by 2. So if you take a as minus half and b as 3 by 2, you can write 1 minus v as minus half 2v plus 1 plus 3 by 2. Nothing wrong in that. That is, if you will simplify again, you will get 1 minus v. So you can write it like that. By writing it like that, you can separate them. This one, you separate it here. This one, you separate it here. And then you integrate both different ways.
Done, sir.
Okay. So have you understood the homogeneous? So homogeneous part was only that you have to write, when you change it into homogeneous differential equation form, you have to write y is equal to vx, which will change dy by dx is equal to v plus x dv by dx. then the whole equation will be in terms of v and x. Then you have to solve that by variable separable. And finally, when you'll get the answer, write back v is equal to y by x. Because if y is equal to vx, v is equal to y by x. So this is all you have to do, right?
Yes.
So if I ask you to do some questions from 9.5, so you could do 4 and 7 and 14. 4, 7 and 14. Three questions you can try. I'm coming in 2-3 minutes. Meanwhile, you can try these questions. Yes, Darnell, you need to ask anything?
Oh no, so I'm doing.
Okay.
So for the fourth one, I got log mod of y by x whole square plus 1 mod plus log mod x is equal to c.
1 second, 1 second. Can you tell me again?
Log mod of y by x whole square plus 1.
Okay.
Plus log mod x plus c. Oh, so the whole y by x square is in mod. It's log mod y by x whole square plus 1 mod.
Okay. So no need to write mod because it is already positive. It is a square. Equal to, where is equal to?
So equal to c. Log x. So log mod x is equal to c.
Okay. So it was x square minus y square dx plus 2xy dy. And then we have dy by dx is equal to dy by dx is equal to y square minus x square by 2xy. It will become, right? And then you put y is equal to v by x, vx, v plus x dv by dx. It will become, and this will be v square minus 1 by 2v. This will become, so it will x dv by dx is equal to, so it will become minus 1 minus v square by 2v. When you will integrate it, to v by 1 plus v square is equal to minus tx by x integration dv. So this will be log of 1 plus v square, that is fine, is equal to minus log of x. So it will become plus and go this side. Yeah, fine. The only thing is that you can further simplify it. Like this can be written as generally simplify this y square plus x square by x square plus log x is equal to c. You put mod also if you want. So here mod is can be put here, but here it is not required. It is already is positive. Log of y square plus x square minus 2 log of x mod you can write, because log x square will become in minus, plus log mod x is equal to c. So log of x square plus y square minus 2 log mod x plus log mod x is minus log mod x is equal to c. So this will be your answer.
Done, sir.
Okay. So the next question is 7th and 14th.
So for the seventh one, I got mod sec y by x is equal to c.
Okay, 1 second. Can you tell me again?
So mod sec y by x plus is equal to c.
This one.
So sec, so or sec in mod sec y by x.
Mod sec y by x. This one.
Yeah.
Sec y by x is equal to c.
Yes.
Okay. So you have taken y by x as v, x cos v plus. First, let us take it there. So this will be dy by dx, v plus x dv by dx is equal to y by x will be v cos y by x plus v sin y by x upon v sin y by x minus cos v. These are also v. So this is what we are getting now. X dv by dx is equal to v cos v plus v square sin v minus v square sin v. It will cancel, and then plus v cos v will get by v sin v minus cos v. This will also get cancelled. And in the next step, we'll take v sin v minus cos v by 2v cos v is equal to dx by x. Okay. So now v cancel tan v by 2. So tan v is log of sec v. So half minus 1 by 2 log v is equal to log x plus c. Fine. So when you put log of sec y by x, here you can't do anything. This is inside sec into half. Here when you put minus half log y and minus plus half log x, that will cancel. No, that will not cancel. That will become half log x here plus c. So you get as half will adjust in c log of sec y by x is equal to log of x into y plus c. 2c will also be c. Now you can remove log by writing it log of sec y by x by y by x is equal to c, and sec y by x by y by x is equal to e to the power c is also a constant c. So sec y by x is equal to c y by x. Did you say this?
Yes, sir.
Okay, perfect. So you said sec of y by x is equal to c y by x. Mod is not required because since you are removing the log, no use of mod now.
So the c y by x, you can take a c, right?
Sorry.
The c y by x, you can take a c, right? Take the whole thing as c.
No, y and x are variable. They are not constants. Whole thing cannot be C. Na? If it is 2, like 2 can go there, 2C will be C. But X and Y is there, then it can't be C. Na? So you made this as C or you got C?
No, sir, I made it as C.
Okay, that you can't do.
Okay.
So 14th is the next last one.
So for the 14th one, I got cos y by x is equal to log of x plus log of e.
Okay, 14th one also you did. What is the answer for 14th one?
Cos y by x is equal to log of x plus log of e.
Your voice is too low.
So cos y by x is equal to log mod of x plus log e.
Log E is 1 basically. So can you check the answer from the back? If it is not required, we will not discuss.
So it's log of mod of ex on the right hand side.
That is okay because log of mod X and 1 is log of E. So you can apply the property and you can write it as log EX. That is fine. So we can move on to the today's 1 hour class or 1.5 hour class.
Yes, sir, it ends at 5 over there. So
That means it started at
it started at 3:30.
okay, and it will end at 5.
Yeah, right now it's 4:20.
Okay, okay. So if we come to linear differential equation, I think we can finish this chapter today. So linear differential equation is the last one of solving a differential equation. If a differential equation is of this form, dy by dx plus py is equal to q, where p and q are either constant, either functions of x or constant, but not a function of y. That is what they want to tell. For example, they have given that dy by dx plus y is equal to cos x. So this is a linear differential equation. Why is it linear? Because here p is 1, which is a constant, q is cos x, which is a function of x. So it is a linear differential equation. The coefficient of y is p, and the right hand side this is constant q. Next example could be like dy by dx plus 1 by xy is equal to e to the power x. So this is also linear differential equation. Here you can see p is 1 by x, which is a function of x, and q is e to the power x. Sorry, I went to close the door. So you can see that here p and q are a function of x. That is, they are not a function of y. Either they can be constant or function of x. There is another type of linear differential equation also where,
So what's LDE?
sorry,
What's LDE?
linear differential equation. Okay.
Yes, sir.
Now, if it is like dx by dy, so you can say p dash x is equal to q dash form. This is also a linear differential equation. Here, p dash and q dash are functions of y or constants. So, for example, for this one, you can have dx plus by dy plus x is equal to cos y. So p dash is equal to 1 and q dash is equal to cos y. Or you can have dx by dy minus 2x by y is equal to y square e to the power minus y. So p dash is equal to minus 2 by y and q dash is equal to y square e to the power minus y. So these are function of y. So basically, if it is dx, dy by dx, so there will be a different situation of LDE. If it is dx by dy, there is a different situation of LDE. But both are similar type of situations. You can understand and relate both of them. Okay.
Yes, sir.
Now, how to solve an LDE? So let us take an example here. This one I am taking. This one, let us take dy by dx form. Dy by dx plus y is equal to cos x. Dy by dx plus y is equal to cos x. So our purpose is to find p. P is 1 here. After finding p, integrating factor, that is e to the power p dx. This is called integrating factor. So here, if you find integrating factor, it will be e to the power integral of 1 dx. That is e to the power x after integration. Now, you have to do one thing, that from the integrating factor which you got, you multiply the left hand side and the right hand side. Now you can write it like this, that this is derivative of y into e to the power x with respect to x is equal to cos x into e to the power x. So this will what happen when you multiply with integrating factor always. Whenever you will have dy by dx plus py is equal to q, and you multiply with e to the power integral of p dx, which is the integrating factor, on both the sides, the left hand side will become derivative of y into e to the power integral of p dx with respect to x is equal to q e to the power integral of p dx. So this is what is happening here also. So this is a rule, and this can be applicable everywhere. So even if you differentiate, you will get e to the power dy by dx plus y into e to the power x. So after doing this, what you do, that you simply, the left hand side part, you can write it d of y e to the power x, and cos x into e to the power x you can take on the right into dx. Now integrate here and integrate here. The left part is y into e to the power x after integration, because integral of a derivative is the same thing. And the right part is a function of x, and now the question of integration remains. You integrate it and get the answer. So this is the whole process. Have you noted it down?
Oh, yes, sir.
Okay. So if we see few questions first from the exercise, like should I tell you an example, or you will be able to do?
So, I like an example.
Okay. So let me give you from exercise 9.6 a question number 5. So question number 5, I am doing it here from exercise 9.6. It is cos square x dy by dx plus y is equal to tan x. Where x is between 0 and pi by 2. Pi by 2 is not included here. Okay, this condition has nothing to do much here. So let us divide by cos square x first. So this will be dy by dx plus sec square x into y is equal to tan x by cos square x when you will do. So sin x into okay, tan x into sec square x it will become. Tan x into sec square x it will become. So we have divided throughout with cos square x. This you understood?
Yes.
Now you can see that this is P and this is Q. So we have to find integrating factor, which is equal to e to the power integral of P dx. E to the power integral of sec square x dx. That is e to the power tan x. This is what we will get. Now we will multiply by e to the power tan x both the sides. So here also we'll multiply e to the power tan x. Here also we'll multiply e to the power tan x. After getting the integrating factor. So left hand side will become automatically derivative of y into e to the power tan x. That you can check. By chain rule, this will happen. First e to the power tan x into dy by dx. Then y will not be differentiated, and e to the power tan x differentiation is e to the power tan x into sec square x. And the right part is tan x into sec square x into e to the power tan x. This is what we will get. After doing this, you write it like this. This is derivative of y into e to the power tan x is equal to tan x sec square x e to the power tan x dx. Integrate both the sides. When you will integrate the left hand side, it will be y into e to the power tan x. And when you will integrate the right hand side, tan x is, you can take as t. So sec square dx will become dt. It will be t into, here also it will become t, e to the power t dt. This is for integration we are doing. Let t is equal to tan x. This is all integration now. So this is by parts. First function integral of second minus integrator derivative of first integral of second, like this. After this, t e to the power t minus e to the power t again plus c. Now you put t as tan x. So tan x into e to the power tan x minus e to the power tan x plus c. This is y into e to the power tan x. Now we generally do one thing, that so many e to the power tan x are there. So we take it, multiply with e to the power minus tan x and make it as y is equal to tan x minus 1 plus c e to the power minus tan x. So this will be the final answer. Can you check this answer from the back of the book? This is question number 5 of exercise 9.5.
Oh, yes, sir.
Okay, so you can note it down if you have not noted it. It started from here.
So I didn't understand the part after you did the integrating factor, the dy into e tan x form.
So after that, what we do now? Derivative of y into e to the power integral of p dx. That is the integrating factor. This is what we get basically. So that is what we have written. And it is quite natural because if you like do the derivative of this, just see here, if you do the derivative of this, you'll write y into derivative of e to the power tan x, that is e to the power tan x, and further derivative of tan x is sec square x. Plus now e to the power tan x will be remaining as it is, and derivative of y will be dy by dx. So this is what you will get. This is what you are getting also.
So how did dy by dx plus sec square x change to y into e raised to tan x?
How does?
So how does dy by dx plus sec square x change to y into e raised to tan x? So the
we
step in green changed to the step in black, right?
yeah, so we multiplied with integrating factor. No, this is the integrating factor. This we got here. And this is what we do in linear differential equation. We multiply the left hand side and the right hand side both by the integrating factor. So after getting the integrating factor, we multiply both sides by the integrating factor. There is nothing wrong in multiplying the same term on both the sides. So we do this. What is the benefit of doing this? Is that we can write the left hand side like this, which we have written.
So I didn't understand how sec square x e raised to tan x changed to just e raised to tan x if you differentiated it.
Okay, let me again tell you. It is dy by dx, okay, plus sec square x into y is equal to tan x into sec square x. This is fine. This is what we have got after dividing by cos square x.
Yes.
Now integrating factor is e to the power integral of p dx. P is sec square x. This is p. When you integrate it, you get e to the power tan x. So after getting the integrating factor, we multiply with that integrating factor on the left. So it will get multiplied to each term on the left and on the right also. We can multiply with anything on the left and right both. So we have multiplied here with e to the power tan x, unless it is not 0. So this is left side will become d of y e to the power integral e to the power tan x. Can we write this left hand side like this?
So where's the sec square x going?
That is the derivative of tan x. That is the derivative of
But
tan x.
how are we supposed to like know it though? Like do we do the whole thing
Your voice is low.
So, but how do we like find it out? Like from y e tan x, it's possible to find the sec square x, but how do you do the inverse?
Now when you differentiate this, now you will differentiate this. This will be like e to the power integral, e to the power tan x into derivative of y plus y into derivative of e to the power tan x will be e to the power tan x into sec square x by chain rule. This isn't this what we are getting here?
Yes.
So it is the rule now that whenever you have something like this, that dy by dx plus py is equal to q is there, linear differential equation is there. So this is a rule. That is what we have studied. That integrating factor, we find it out as e to the power integral of p dx. What is the benefit of taking this integrating factor? That when we multiply it on the left, like this, and as well as on the right. So this left part will automatically become, you can check by doing the product rule of derivative. This will automatically become the derivative of this whole term, like this. Okay. You can check
Yes.
that if you write it like this, that this is first term e to the integral of p dx dy by dx plus y, and e to the integral p dx derivative is e to the power integral p dx into derivative of integral p dx is simply p. So this chain rule will apply here. So you will get the same thing. So you can write it like this. Now this is derivative of y into e to the power integral p dx, whatever you get the integrating factor, is equal to q into e to the power integral p dx into dx will go there and it will both be integrated. Now the left hand part, integral and derivative will cancel and it will be y into e to the power integral p dx, and the right part you have to find out. Are you getting it?
Yes, sir.
So this is what we do in linear differential. That I showed you by an example. So the same thing which we are doing here, that we have taken integrating factor, that is e to the power integral of p dx, which is e to the power integral of sec square x dx, which becomes e to the power tan x. So integral we get rid of it, integral, and we write it as e to the power tan x multiplied. So we write it as like this, y into e to the power tan x, and right hand side also we multiply e to the power tan x. Okay. Hello.
Yes. Well done, sir.
Okay. So I'll try a few questions. Question number 9 you can try, and question number 12 you can try, and question number 17 you can try.
So for the ninth one, I got P as 1 by x and I got P as 1 by x plus cot x and Q as 1. And for the integrating factor, I got x sin x.
Okay,
How do I proceed?
1 second. So dy by dx, and then you have x division you have done. So it will become 1 plus cot, sorry, dy by dx plus y by x. And here it will get cancelled, y by x minus 1. And here it will cancel. 1 second, 1 second. I will have to write it first. Because when you write it as dy by dx, it will become plus y by x minus 1 plus y cot x equal to 0. Now, you can write it as dy by dx plus 1 by x plus cot x into y is equal to 1. Now, this is in the form of linear differential equation. Are you getting this?
Yes.
So have you got this one?
So yes, so I got P as 1 by x plus cot x and Q as 1.
Okay, now what is the integrating factor that you are getting?
E raised to log x sin x.
Okay, e to the power, this will be log x, and this will be cot x integration will be log of sin x. So that will be log of x sin x. Now there is a property of natural log that e to the power log of anything is x sin x. E and log will cancel. They are inverse function of each other. Okay.
Okay, sir.
Anything just log a to the power log b to the base a is there, no? This will become b. Similarly, e to the power ln b is there. The base is actually e here. So it will become b. So this is the integrating factor which you have to multiply both the sides. Okay.
Yes.
Would you proceed? Like to proceed?
So I'm not sure what to do after this.
Okay. So when you multiply with x sin x, it will become x sin x dy by dx plus, and this will x cancel. It will be sin x, and this will become x sin x into cos x by sin x will be cos x only, into y is equal to x sin x. So when you will multiply this x sin x on both the sides to each of the terms, you will get this. Can you understand this part?
So please can you repeat?
Sorry.
So I didn't understand.
So if you multiply x sin x on both the parts, what will happen? That x sin x is multiplied here. X sin x will be multiplied here. And x sin x will be multiplied here. And x sin x will be multiplied here. So this is x sin x dy by dx. This x cancel and only sin x you get. Here cot x is actually cos x by sin x. So sin x will cancel and cos x cos x you will get. And here x sin x. Would you get this?
Yes, sir.
Yeah. Would you get this?
Yes, sir.
Okay. Now what will happen? It will become derivative of y into integrating factor, that is x sin x on the left side. And on the right side, it is x sin x. That you can verify also. That is, you can see x sin x as one term and y as another term, and write it as first term x sin x into dy by dx plus y as another term, and derivative of x sin x will be sin x plus x cos x. So the same thing we're getting. You can verify also, you can write upfront also if it is integrating factor getting multiplied. So it will be y into x sin x after integration here, and this will be x sin x dx integral. Would you get this?
Yes, sir.
Okay. So this will be xy sin x, and here you will again apply the chain rule. So x sin x, x into minus cos x, that is first function integral of second. Then it will become plus integral of cos x dx like this. This will become minus x cos x plus sin x plus c. So finally what you are getting is xy sin x is equal to sin x minus x cos x plus c. So you can check the answer.
Oh, yes, sir.
Okay. So you can write it down, and next you have to try is question number 12. Question number 12, I think that it may not be of the form dy by dx. It may be of the form dx by dy. Y and x role will be interchanged. It may be possible as it seems.
So how do you simplify e raised to log y inverse?
This one, log y inverse like this.
Yeah, yes, sir.
So e and log will cancel. It will be y inverse. That is 1 by y.
Okay, sir.
But it will not be log y inverse, na? Integrating factor will be log y only, because you are integrating 1 by y.
So I'm integrating minus 1 by 1.
So minus 1 by y, that is, okay, you are saying that. 1 second. Minus 1 by y log y. Yeah, then it is okay.
So x is equal to 3y square plus cy.
You can see from the back, if it is okay, then we will not discuss.
Oh, yes.
Okay, good. So one last question. Okay, time is almost over. Would you like to do 17th or you will do later?
Oh, yes, sir. I'll try doing it now.
Okay, question number 17th. Let's try this one.
So for the magnitude, we'll take dy by dx, or the mod of dy by dx.
Uh, it's the magnitude of the slope of the tangent. That is mod of dy by dx actually. So there will be two cases. When you will remove mod, it will become plus minus dy by dx. Two cases will be there.